Good morning, everybody. Today I'll start HVC's other part, that psychrometrics or psychrometric chart and its effect and why it is required for your your marine systems. We'll try to discuss. So basically, the things content has been taken from Basic and Applied Thermodynamics from PK book, chapter 15, and something from other internet sources. For example, the left side table it is taken from weather.com. Okay, for different cities you can see the temperature and humidity. Temperature Chennai 38, humidity 61. Sometime relative humidity will go to 70, 80 also, sometime 90 also. So you see the different temperature and different humidity in different cities, then which is comfortable. So for to find the comfortable zone, actually you have to go through psychrometric chart. Okay, psychrometric chart. Okay, so this chart says what will be your comfortable zone for human comfortable zone. You can see here, this is called the x-axis is called dry bulb temperature. Later we'll discuss what is dry bulb, and there will be wet bulb temperature, WBT. So wet bulb line will be like this, dry bulb line will be like this. Okay, so if you know wet bulb and dry bulb temperature, based on that actually you can find our comfortable zone, whether present weather is under comfortable situation or not, we can find that. And same temperature, if you have different humidity, your comfortable feeling will be different. For example, in the top left corner we have one picture, it is showing 28 degree centigrade temperature both, but one humidity 60 degree, another humidity 85%. Okay, so 85% people will feel more hotter. This is more hotter than this one because temperature is higher, and sorry, temperature is same but humidity higher, because skin temperature, because if any water molecule coming out from the body, that will not get evaporated with temperature same but humidity higher. So in that case you will feel very much uncomfortable at higher humidity, all the temperature is the same. And this is from Back in India website. And normally our in Indian condition comfortable temperature will be about 25 degrees centigrade, humidity will be about 60%. And this also varies. For example, someone is in the Scotland, they may feel 25 degrees very much higher temperature, but in Chennai many people say it is lower temperature, so they will try in Chennai people will try to keep temperature 25 or more normally, but in Scotland they'll be trying to put their temperature, AC temperature, less than 25 normally. And humidity, well, comfortable normally 60% around, maybe 50-60%. So let's say for our study purpose, assume comfortable temperature 25 degree, humidity 60%. And again this is based on the location, geography location. If you are from, let's say, Alaska or from North Pole, then your comfortable temperature level will be different than who are there in Chennai or South Africa. So before discussing further, we'll try to discuss dry bulb, wet bulb temperature. Let's say I have one thermometer, another thermometer. Okay, so thermometer normally if I put outside room, then it will be showing atmospheric temperature. Okay, so maybe your mercury level will be showing here. Let's say this is 30 degree centigrade. Okay, now I have another thermometer which will be having some wick, cotton wick, maybe cotton wick, and soaked. So what will happen, the cotton wick will be evaporating lots of water molecule from around the bulb of this mercury. Okay, so that will take latent heat will be reducing temperature of that area. Okay, so the dry bulb temperature will be lower than my wet. This is called dry bulb, this is wet bulb. Okay, so dry bulb means there is nothing here around this mercury area. Okay, so temperature will be higher, but if I put some wick and if we add water there, so wick is soaked, then the water will take lots of heat, latent heat, that will reduce the temperature of the bulb area, and my temperature will be showing maybe 25 degree. Okay, for example, I'm giving 30 degree maybe dry bulb temperature, wet bulb will be 25 degree. So in that way, if you have two thermometer, actually you can find what will be your relative humidity, what will be present temperature, so that you can find. And to find this one, actually you have to use on psychrometric chart, because psychrometric chart will have, this is dry bulb temperature, or dBT, wet bulb temperature it will be showing, so it will be WBT. So dBT here and WBT here. So there, say dry bulb temperature 30 degrees, so 30 degree lines will be vertical in your psychrometric chart. Normally this vertical lines will be dry bulb temperature, maybe 20, 30, 40, 50. Okay, and wet bulb temperature will be like slant lines. Okay, and let's say you get wet bulb temperature here. Okay, so this will be like 25 degrees centigrade, and it is crossing wet bulb dry bulb temperature at certain point. So that point will be giving you the relative humidity, because relative humidity lines will be like this. This will be your relative humidity lines. Okay, so this relative humidity equals 100%, the top line. Then after that 90%. If you see any psychrometric chart, then top line will be 100%, then 90%, then 80%, 80%, then maybe 70%, then maybe 60%, then maybe 50%. Okay, so this way the amount of water content in the air you can find. If you know dry bulb temperature, if you can design on wet bulb temperature, just we put around the thermometer, it will be reducing temperature. So you know wet bulb temperature, you know dry bulb temperature, and the crossing of that line nearby relative humidity you can check. And if it is nearby, like say 60%, 50%, then you can say okay, it is comfortable temperature, and 30 degree maybe Chennai people will say this is okay for me. Okay, but in many cases you will feel very much hot in 30 degrees centigrade, or maybe sometime in summer Chennai temperature maybe 40 degree in Chennai. So if it is 40 degree temperature and dry bulb temperature is showing 25 degree, so 40 degree means here, and it is touching here, so your relative humidity may be very low. But okay, so in many cases if you have very high humidity plus high temperature, so in that case actually you have to modify humidity and you have to modify temperature, so that room will be comfortable. Okay, so later we'll discuss how to modify the temperature using air conditioner system. And dew point. Dew point means when the 100% relative humidity is there, so that point line is called dew point line actually, because if you want to add more moisture, it will be creating small water bubbles. Okay, water will be condensing from air. So air is having certain amount of water already, and if you reduce temperature actually, so some water will be separated from water, so that is called dew point. Okay, the temperature will be dew point and the line will be 100%, relative humidity will be 100% in that condition. Okay, psychrometric chart I already told. This one line is here, is curved line. Okay, this is wet curved line is called relative humidity 100%, RH equals, this is 100%. Okay, and this dry bulb temperature dBT in degree or Fahrenheit. Many chart they will be giving in Fahrenheit, and many chart they will be giving in centigrade. So let's assume we are using centigrade scale, x-axis centigrade scale, and we have this curved line. This is called wet bulb temperature, or WBT. Okay, this figure I have taken from Wikimedia, but again I modified because this line I redrawn. Okay, and 100% relative humidity, then 80%, 90%, 70%, 60%, 50%, 40%, 30%, 20. Okay, so if you go from top to this side, so your relative humidity is going down. Now your wet bulb temperature will be like this. Okay, so these are slant lines, these are wet bulb temperatures. Okay, WBT, this is also again centigrade. So normally if I say wet bulb temperature 30 degree in presently, so 30 degree means 100% saturation is there. Okay, if I increase temperature, then it will be unsaturated. Okay, let's say certain amount of air you take and you reduce temperature, so once you reduce, air moisture carrying capability will be lower. So in that case, at lower temperature, air will be saturated with the present amount of air, water. Okay. Now sensible heating and cooling. We have seen our wet bulb temperature and dry bulb temperature. This is DBT or dry bulb temperature, and this is wet bulb temperature or dew point temperature or saturation temperature. Okay. Now dry bulb temperature lines will be vertical lines and wet bulb temperature will be slant lines. Okay. Now if I increase, let's say you take certain amount of air, increase temperature. So if you increase temperature, actually relative humidity will be going down. Okay, how do you know? So let's say my present condition is here. Now increase temperature. Okay, OA, you are increasing temperature. So OA means this sensible heating. So when you are sensibly heating, so your actually relative humidity will be lower. Okay, relative humidity, because you see these lines 100%, maybe 70%, 60%, humidity lower. Okay, when you are heating, you are not adding extra moisture or you are not removing moisture from air. So in that case, your temperature increasing, so your relative humidity will be lower. But again, if you are cooling same air, let's say B line, okay, then what will happen? You're cooling, so temperature going down, relative humidity will be increasing, although you are not adding moisture. But after certain time, it will be 100% saturated. Saturated means, so when you are reducing temperature, air will be saturated. Saturated means air cannot take more water. Okay, so you take when you are reducing temperature, air will be saturated, although you are not adding water. Okay, so you take certain amount of water, certain amount of air, atmospheric air, you reduce temperature. So after certain time, certain reduction of temperature, water will be completely saturated. And if you reduce further temperature, what will happen? Certain water will be condensing and it will be forming water droplet at the bottom of the pot. Okay, so that point, water starting create the droplets. This is called dew point temperature. Okay, so this will be touching the 100% relative humidity line. But if you are increasing, then that situation will not come. In that case, actually your relative humidity will be going down. So take certain amount of air, reducing temperature will be increasing humidity, increasing temperature will be reducing humidity. Okay, because air is having water carrying capacity, certain amount of water it can take, but it cannot take more than certain amount of water at certain temperature. Okay, when it is 100% saturation, it will not take more water. Especially during rainy season, if you see, cloth will not get dried. Okay, so what happens during rainy season, in Kolkata or Chennai, and like several days continuous rain will be there, so humidity will be almost 100%. So in that case, cloth will not get dried and it will be smelly also. So because high amount of moisture is there, it will not get dried, so lots of bacterial growth will be there because of high moisture, and your skin disease also may come up actually because of high moisture, like eczema and other sort of disease during rainy season you will find because of moisture. Your skin will not get dried quickly. Okay, so in that case you will not feel comfortable, so you have to reduce moisture that time. Okay, although temperature is lower but humidity higher, so you will not, because of humidity higher, you will not feel comfortable. Okay, but if you can remove the humidity, the same temperature, you will feel very much comfortable. Now you see this one, process 0 to 1, sensible heating here, sensible heating is here. Then what will be sensible cooling? Just opposite of this one, sensible cooling. Okay, so let's say A I made is sensible So if I ask you sensible cooling, then OA. Then if you have chemical dehumidification, so if you are using certain chemical, then your humidity can go down, your temperature can go down, you can manipulate. Okay. And cooling and humidification 0 to 3. What is happening? Cooling and humidification. So first, once you are starting cooling, so temperature will be going down. At the same time, if you see, it will be crossing your so cooling and dehumidification means you are reducing, you see this temperature is going down, and again you see right side is showing amount of humidity is there. Okay, specific humidity means how much water content is there in air. So 0 to 3 you are going, that means you are reducing water content, dehumidifying, and at the same time you are reducing temperature also. So it is going to 0 to 3. Again 0 to 5, just opposite is happening, heating and humidification. You are adding humidity. Okay, so 0 to 5 you see humidification with steam injection, means you are adding more moisture. Okay. Okay. Now I have moisture in air. How to measure? So there is hygrometers. The term is called hygrometer. So sometimes they are calling moisture sensor, humidity probe, psychrometer, or humidity meter. So here you should remember the spellings, not psycho. This is psychro. Okay, R is there. So a hygrometer is a device used to measure relative humidity in open enclosed space. Okay, mechanical, electrical, and many other type of hygrometer people develop so that they can measure specific humidity. Once you know the relative humidity, specific humidity, accordingly you can design your air conditioner. Okay. Mechanical hygrometer, like organic substance like human hair also can be used for your hygrometry. So with a water content, human hair can be changing its length. Okay. Electrical hygrometry is also there. It will be changing your resistance property of wear. So that way you can measure humidity content in air. So another is dew point hygrometer is there, and psychrometers are used to find wet bulb and dry bulb temperature. So if you know the relative humidity and if you know your dry bulb temperature, then you can manipulate to your wet bulb temperature also. Okay, now we'll go to some formulation properties of atmospheric air. So atmospheric air pressure, equals PA plus PW. So partial pressure of air, and PW partial pressure of water in the air. Okay, or water vapor you can say. Okay, so mole fraction, dry air, mole fraction of dry air equals PA by P, total pressure, and P equals 1 atmospheric pressure we are assuming. Okay, so that means PA X equals XW PW by P, again P equals 1, so it is PW. Okay, in volume, temperature and pressure, V equals V1 plus V2. So if we use this formula, it N1 RT by P plus N2 RT by P. So V1 volume of dry air, volume of water vapor. Okay, so N1 N2, your N1 and N2 is your mole number of moles. So x1 equals p1 by p equals v1 by v equals n1 by n. Okay, so mole fraction x1 equals p1 by p equals, okay, this is mole fraction. Okay, mole fraction I do not need to write, it is here. Okay, now m capital M equals m small m capital M small m capital M 1 1 2 2. So capital M equals x1 m1 plus x2 m2. x1 x2 is a mole fraction. Okay, U is internal energy, so mu equals m1 u1 plus m2 u2. So this is Gibbs law. Okay, so U becomes m1 u1 plus m2 u2 divided by m1 plus m2. Okay, and if I write in terms of enthalpy, mh equals m1 h1 plus m2 h2. Therefore H equals m1 plus h1 plus m2 h2 m1 plus m2. M equals m1 plus m2. So specific humidity or humidity ratio, TS diagram will draw. Okay, actual temperature of moist air called dry bulb temperature of moist air and G equals mass of dry air, M equals mass of water vapor. So W equals M by G equals V by V, VW, V by VA equals VA by V. Okay, so humidity ratio, this is called humidity. This is small w actually, humidity ratio, this one. Now this is TS diagram and TD is a dew point temperature. Superheated state of water vapor. Heated state of water vapor in unsaturated air, so in atmospheric, the water vapor will be in superheated state. Okay, saturation pressure P water. Now PW is very small, the saturation temperature at PW is less than T atmospheric. So water vapor in air exists in superheated state. Okay, water vapor exists in air is superheated state and air is said to be unsaturated. Okay, since both dry air and water vapor behaves individually as ideal gas, so PA VA equals PA VA equals RT by MA and VPA equals GRT MA, then PW BW equals RT MW PW V equals MW RT MW bar. So G is dry air mass, already I have written, M capital M is molecular mass. Okay, so PW, VW, uh, now specific humidity ratio. So MWPW by MAPA equals 18 molecular mass 18.016 divided by 28.96. So it is coming 0.622 PW by PS. Okay, when W is in kg water vapor per kg of dry air, W in kg of water vapor per kg of dry air. Okay, so relative humidity DITY, relative humidity or RH, or sometime many people will be writing phi also. RH equals partial pressure of water vapor at certain temperature, the same temperature saturation vapor pressure, into 100. Okay, so the ratio of amount of moist air relative to the amount that can be given, that will be absorbing more water. Relative humidity 100% means it will not absorb more water, but relative humidity less than 100% but means same temperature it will be absorbing more water vapor. Okay, so these two ratios at the same temperature, like say certain temperature you have certain amount of moisture, and the moisture, total moisture will be there if relative humidity 100%. So the two ratio is called relative humidity. Okay, temperature and humidity control. So what happens, like say certain today temperature is, for example, let's say 35 degree centigrade and 30% relative humidity. Okay, now if I ask you make it 25 degree centigrade and I need humidity 60%, what will you do? This is 60% line and this is 25 degree centigrade temperature. Okay, so initially you, let's say today 35 degree centigrade and let's say 30, let's say 30% efficiency humidity. Okay, so but you have to go to comfortable temperature 25 and 60%. So what will you do? So first take 30 degree line. Okay, 35 degree line here and 30% efficiency here, so this point, then you have to reduce temperature to 25. 25 is here, but you need humidity 60%. Okay, so what you do, you reduce temperature, but you are not reaching that humidity. So what will happen, you reduce temperature, then you have to add some moisture also. Okay, then you add some moisture, and make it comfortable. Okay, you can see if we reduce the temperature directly, sensible cooling, so it is crossing 60 degree here, so it is more than 20 degree, but still you are not reaching your temperature, desirable temperature. So what do you have to do, you have to add more moisture actually. So in that case, if you add moisture, then only you can reach your 60% humidity. Okay, so only cooling is not helping you, rather you have to increase, add some moisture also. Okay, so that how can you do that one? So if you use desert cooler, in North India you are using desert cooler, right? So in desert cooler what happens, you have one cotton wick or some coir will be there, through this one air will be passing and you have lots of water splashes. So that water splash will be adding lots of moisture. When we are adding moisture, actual temperature will be going down directly and it will be reaching your humidity nearby 60%, then you are feeling comfortable, that's fine. But in certain situation, let's say assume present temperature is 35 but your humidity is 70%, 60-70%. Okay, if you are having 70% humidity, let's say 70% relative humidity, and your temperature is 35 degree. Okay, so what will happen if you add moisture? So if you add moisture, your relative humidity will be increasing. So if you are increasing relative humidity, temperature will be going down. Okay, so temperature will be going down, but your relative humidity increasing. So that will be very much uncomfortable. So then what you have to do in air conditioning system, what they will do? They will reduce temperature. Okay, let's say O, A, then A to certain level they will be reducing temperature further. Your target temperature 25 and here. Okay, so reduce temperature, reduce, and you go to here. So B, C. So if you this one you want to make comfortable, then what you have to do? OA, first you cool it, then you cool further A to B. A to B, what will happen? Lots of moisture will be condensed, some water particle will be drained out. Then again B to C, you increase temperature. When you are increasing temperature, you are maintaining that 60% and your desired temperature. Okay, then you are reducing moisture as well as your temperature. But if you have already low moisture, then actually you cannot reduce moisture. So in that case, you can add moisture. When you are adding moisture, you are making your room comfortable. So North India, you can see lots of desert cooler will be there. So desert cooler will be reducing your temperature and humidity, increasing humidity. Okay, but in South India, if you are using same desert cooler, it will not help because it will be adding more moisture. So that will make your life more uncomfortable. Okay, so Southern India, especially Chennai or Kolkata, you need air conditioner which will be draining out some water from air. So whenever you see any air conditioner, especially split air conditioner, there will be long pipe coming out and some water droplet will be there. Okay, so those water droplets actually your condensed water, because you are modifying humidity also. So dew point temperature. So TS diagram if you draw, so your vapor envelope, then your pressure line will be like this, PS saturation line, P water line, and D1 PW, this is PS. So saturated water in vapor. So point 2, you see saturated water. 2 is saturated water vapor in saturated air. Okay, but point 1, this is superheated water. Superheated vapor in unsaturated air. Okay, so moisture maximum can be Ws equals 0.622 PS P minus PS. Okay, so maximum moisture means like saturation state, your how much moisture will be there, so that formula is this one. But normally it will be, instead of PS you will be putting PW. Degree of saturation. Degree of saturation, so 0 to mu to 1. The formula is this, W by W is saturation, PW PS, P 1 minus PS by P, 1 minus PW by P. This formula you should remember. Okay, so if dry air is there, dry air, PW equals 0, mu equals 0, and saturated air, PW equals PS equals mu equals 1. So relative humidity. So this small formula is there. Based on this, we will try to solve problem. Relative humidity, phi equals m mass of water in saturation condition. So PW V by RT bar PS V by RT, PW by PS. Okay, so ideal gas condition you have to apply. Phi equals V by VW, V by Vs equals Vs by VW. Ideal gas P1 V1 equals V2 P2. Phi equals PW by PS, Vs by VW. So PW equals PS implies phi equals 1. So air is 100% saturated, 100% saturated. Or relative humidity RH 100%. W equals 0.622 PW P minus PW. You should remember this formula. Okay, so equals 0.622 PW by PA. Phi equals PW by PS equals W by 0.622 PA by PS. So phi coming mu 1 minus mu PS by P. Okay, these formulas are taken from your PK book, so you can go through it.